Hello. If anyone's there for the chat, let me know you can hear me to start with. It's kind of a trademark of mine to start without sound. Hello, Bella. Oh, you were here last week, Bella, weren't you? You can hear me, good. And can you hear me clearly? Am I quiet or anything like that? Yay, okay, good. You start with sound, that's always a good start. How are you all doing? We'll wait a few minutes. We usually start like the maths around 5 past, so just so that if any stragglers want to join us, they can do then. What did you miss last week? Last week we did angles and parallel lines. It is on YouTube though, so you can always have a look back on it, Misam. Yeah, missed you here. I did notice that. Notice you weren't there. I hope you were enjoying yourself. I realized for most of you it was probably half term. For some of you, it might even be half term this week. I get very confused with it. I have most students who were on half term last week with me, and then, yeah, this week I have like a couple students who are now on half term this week but weren't last week. So yeah, I never really know. I always thought it was standard before for all schools, but I guess not. But yeah, what have you all been up to? You're in Birmingham, so it's half term where you are in Birmingham this week, Bella. Is that right? Currently, okay. So, do you have any nice plans? I'm very honoured that you're spending the first day of your half term or the first evening of your half term here on YouTube watching maths with me this week. Nice. Have you got any nice plans? Misa, what were you doing last week as well? Were you on half term last week? Were you having a nice time? Ah, okay. So you have inset day today, tomorrow. Oh, school tomorrow, I see. Oh, wow, Alex, you're doing mocks now. Jeez. That's a nice way to welcome you all back. Welcome back. Here's a test. Oh, family meal and watching Netflix. Are you watching anything nice on Netflix? Whatever I was watching this it's probably not the best TV, but it was like some physical 100 or something. And I was getting kind of addicted to it. Like just watching like really crazy fit people doing crazy tasks. I'm well, me Sam, thank you. Um, So, Alex, are you preparing? Have you got your maths mocks coming up? I guess is that like what brings you here today? So for everyone here, so we will start actually in a couple minutes. We are going to be doing angles in polygons today. I've pulled up a selection of questions from different syllabuses. Your first exam on Thursday. Good luck. Yeah, so for today I've put up a bunch of questions from different syllabuses, and they're all shape questions. They all involve using the rules about polygons. So we'll get a bit of practice of there, but they're also quite nice ones. They're ones that when I show them to students, they usually panic because they see shapes and angles and don't really know what to do with them or where to start. So hopefully that'll be quite useful. What else do I do instead of my tutor? So I've just finished up my PhD, and yeah, I've been teaching, writing, all of that jazz. Yeah, and now I've started doing this, I guess. Okay, so let's start. I have already set this out here. So first of all, to start off with, I just want to introduce the rules of angles of polygons, what you need to know. What was my PhD on? So, well, my undergraduate degree was chemistry, and then my PhD is in a physics department. So it's probably more like a chemist in a physics department, but yeah, so I guess technically it will be a PhD in physics, but more physical chemistry. So yeah, I teach maths, chemistry, and physics. on my tutor. So do a little bit of everything. I've been doing it since tutoring since I started my undergrad. So I've tutoring for quite a long time. But yeah, we'll get started though. So I stupidly haven't got my iPad all charged up. So if my writing's a little bit untidy, that's why. I'm trying to set everything up between my two screens. Again, if anyone has watched any other weeks, you'll know I'm not like the most technically adept person, but we will muddle through. Okay, so angles in polygons. This is me just trying to show you the general rules. So the only real rule really is that the exterior angle of a polygon, all of them add up to 360 degrees. And I wanted to show you this to show you why that is and what we mean by exterior angles. So you can imagine for any shape, if I extend out the line and take the angle, like so, if I then squish all them together like I have over here, they will all come together to form like a circle. All the angles will form a circle. And you all know that the circles, their angles add up to 360 degrees. So for a regular polygon, I can just take the number of sides, because that's how many exterior angles there are, and divide it by that number of sides, divide 360 by the number of sides, and that will give me my exterior angle. So is going to equal this. And what that means is the internal angle. So let's add that into the diagram here. So like so, we all know what the interior angle of a regular triangle is, or an equilateral triangle. But you know, like from this, our rules also straight lines, is we can take that exterior angle and take it away from 180. So for our interior angle, we just take 180 minus 360 divided by n. Could I make my camera smaller? I can indeed. Or I can try at least. So let's make it like so. Is that a good size? Let me know if not. And also let me know that has actually done what I think it's done. Okay, so yeah, so therefore our interior angle is going to be 180 minus the exterior, which we've just defined. Really, that's the only angle rule that I care about using today. Often this does overlap with other parts of geometry, but this is the main rule. However, a lot of the time people will learn this rule and then the questions, they won't know exactly when they're supposed to be applying it. So I just want to move on to the exam questions. First, we'll start with a relatively simple one. So the exterior angle of a regular polygon is 45 degrees. Circle the name of the regular polygon. So I would recommend everyone, if you've got your calculator there, have a go at these questions at the same time as I'm working them out. Put your answers in the chat. I am going to look back and forth, but it'll be good practice for you all. So we know from our rule over before is that our exterior angle, which they tell us is 45, is going to equal 360 divided by the number of sides. So here's my equation with the 45 substituted in. I just now want to rearrange to find what n equals. So I'm going to times up by n to say 45n equals 360. Therefore n equals 360 divided by n. Oh no, not by n, by 45. And then I can put that in my calculator. So 360 divided by 45 is 8. And then I can go back to my multiple choice. Octagon, oct is for 8 sides, so that's going to be my answer. So it's a very basic use of this rule. Hope everyone's happy with that. Say on there if you are or if you're not as well. But we're going to just move over to another one level more difficult. This one would still be one of the easier styles of questions. You're all happy with it? Fab. If anyone has any questions, you can just put it in the chat. I will answer any questions you have. Chances are if you have a question, someone else will also have the same question, or won't, and actually they won't have thought about it. It would be useful. So ask any questions you have. They're all good questions. So here in question 12, part of a regular polygon with 15 sides is shown. So we have our polygon, the outline of the shape over here, and they want us to work out the size of an interior angle. So everyone have a go at this again. Put your answers in chat if you can figure it out. If what we, our formula is for an exterior angle, so we can actually extend a line outwards. Just carry this on in a straight line. And then the exterior angle is the angle the shape then makes with that line we've just drawn out. So this is the angle that our formula is for. So 15 sides, we can say that exterior angle, so the exterior angle is going to be 360 divided by 15. So if you put in your calculator, I'm going to do it now too, you should get 24. Just to make sure that I'm also doing everything, and can everyone confirm that that is definitely, everyone gets the same in their calculator. So exterior angle of 24. However, we don't want to know the exterior angle. Could I put the formula for the interior angle? Yeah, sure, we could go straight to that actually. It's up to you how you want to do it. Some people like to only remember one formula and then use it like this. But we could also do it in one and say the interior angle is going to be 180, because that's how much the straight line angles will add up to, minus what we've just worked out. So if you want to do it all as one formula, you could say this minus what we just worked out. However, we just said that that was 24. So our interior angle should be 156. Again, everyone, let me know that you're happy with it. If you have any questions, again, let me know. It's up to you how you want to remember this too. Either you can remember just the formula for exterior of being 360 over n, or you can remember both if you have a really good memory. I personally don't. But if you do, you can remember this as the exterior and then also remember to just take this away from 180 to go straight to the interior angle. So they're the two formulas. You can't see the bottom of my screen. Of course you can't. Okay, wait, let me just zoom out maybe. There you go. Thank you, Misam. Yeah, let me know if there's anything like that going on. Sorry. Yeah, can you all see that clearly now? Thank you, Misam. Fab. Okay, so that's question 12. So they're the two more basic examples of questions. I want to move on to the questions that, when people often see them, set them into a panic mode. And this is one of them. I've done this question with students a few times before, and a lot of the time they actually won't even go into the question. They'll just see shapes and panic. However, this question is not really much different from the one before when you break it down. So we've got in the diagram AB, BC, and CD are three sides of a regular polygon P. So in an exam, you won't actually have this telling you this is a regular shape angles of polygon question. Instead, what you're looking out for is this keyword regular with your shape. The second you see that, you want to be thinking about these rules for how you figure out the angles. So regular polygon, immediately I would write down that the exterior angles are 360 divided by n. So that's the first thing I would do. Okay, so we've got the diagram here. show that polygon P is a hexagon. So they want us to show that this shape here extends outwards like so. So have a little think about this. I'm going to give you a little moment to look at it. If anyone has any ideas of where to start, write it in the chat. Which paper do angles in polygons come, or can they be on any? So that question, it probably does depend on your syllabus. However, for most syllabuses, all of the maths topics could be on any paper. Is just for the non-calculator paper or calculator paper, whichever ones are kind of more appropriate for that. Like whether you need to be doing complicated divisions or calculations you could do in your head. So technically either for most syllabuses, but double check for yours. Yeah, I hope that answers your question. Could be on any. For most syllabuses, just before the exams, they will release some advanced information. And that might give you a little bit more information on what paper it will be on at the time. It usually comes out about a month or so before the exams. But until that comes out, I would assume that anything could be on any paper. Any topic could be on any paper. Okay, I've given everyone a little bit of time to have a look at this question. So we have this formula. If we can find any angles related to P, then we could use those to work out what n is. So this is one of those ones where I would either be looking for an exterior angle, see if I can work one out. I can't see an obvious way to work out an exterior angle. However, I can see that this angle is workoutable because I know this is a 12-sided polygon. Workoutable might not be a real word, but I know that this angle is something that I could use this rule to work out. And also I know the angle of a square already. And then the one I don't know is the final part of this 360 circle here. So I'm just trying to figure out what I can and can't work out. And usually once I've filled in some unknowns, everything else will come together. So angle of a square I know is 90 degrees. This angle I can work out. I already am told it's a 12-sided polygon. So I can do my 360 divided by 12. And that's going to get me like the exterior angle of the polygon, and I could take that away from 180 to find out what the interior angle of the polygon is. So that's the first thing I would do here. So 360 divided by 12 is 30. So if I take these away, I'll get 150. So the and you can see that, right? So I will just move this down to make some space. So the interior angle there, the red angle, is 150 degrees. And now can anyone put in the chat like how I will use this angle plus the angle of the square to find the interior angle of the polygon P? I'll give you a few moments to have a think about it. So I now know that this angle here is 150 degrees. So 360 minus 90. So 360 minus 90 . Oh, minus 150. Sorry, I misread that as an equal sign. I was getting confused. Exactly. Good. Yeah, so I'm saying that all of these angles, the 90 degrees, the 150, and the angle in polygon P, all add up to 360. So if I take those two away, I'll be left with what P is. So if I put that all in my calculator, so 360 minus 90 minus 150 will leave me with 120. And at this point, I have two ways to carry on. either I can carry on using this 120 and I'll show you both. So either I can say that the interior angle of my polygon P equals 120. Let's carry on down the page. And I know that the formula for that is 180 minus 360 divided by n. And then I could use this equation to solve for n, and then eventually I expect n to be 6. And, or the other option I could do is, I could say 180 minus 360 over 6 and show that this equals 120. Let me carry on. So I have two options here. Neither one is wrong. You can choose either method, whatever in an exam feels most intuitive to you. So 300, I'm going to do the bottom one. I think it's a bit easier. So 180, 360 divided by 6 is 60, which gives me the 120. So therefore, n equals 6, and P is a hexagon. Is the 120 for the square or the hexagon? The 120, so we go back to the diagram all the way back up here. The square is 90, and that 150 was for the 12-sided polygon. So you are left over, so that 120 we worked out. Let me get rid of this to make it look a bit nicer maybe, is the angle of the polygon. Because we know that the blue, the red and the black all have to add up to 360, which is why Alex knew you have to take away the 90 and 150 from 360, which leaves you with the 120 over here. Does that answer your question, Misam? Let me know if not. And then we use that to say we now know what the interior angle of that polygon is, and we work backwards from our formula to show that that means that n equals 6, and therefore show it's a hexagon. Let me know if anyone has any questions. So this is all of the working down here. Don't know if I can zoom out so you can see it all. So yeah, so there's all the working. I'll let you have a look at it. Let me know if you have any questions, and if not, we'll move on to the next one. Okay, I'm going to assume that everything is good, and we will move on to the next question. So an equilateral triangle is 120 the final answer? Sorry, I'm just really quickly going to go back. The question over here was showing that it's a hexagon. So 120 isn't, they weren't asking us to work out the interior angle as the final one. Instead, what they're trying to do is get us to show using the formula that n equals 6. So that's why we can say that we know that the formula for an interior angle is 180 minus 360 over n. And then if I replace n with 6, I get back to 120. So therefore, both of these statements are true. So n has to equal 6. I could also take this equation here and rearrange it to find n as well. So the answer is more the whole thing of just showing that all of these statements are true, and therefore if all of them true, it must be a hexagon. What would that be out of? I do believe I can tell you exactly how many marks that question was. It was 3 marks. So 1 mark for getting to the 150 up here, for showing the interior angle of the 12-sided polygon. 1 mark for getting to this formula down here with the 360 over n and taking it away from 360. And then the final mark for rearranging to show 6. So 3 marks for this one. Okay, let's move on to the next question. Now I'm aware of time. So question 10, an equilateral triangle and regular 10-sided polygon and another regular polygon meet at a point. So they don't tell us how many sides. So let's put the pen tool. We don't know what n equals for this polygon. Show that angle A is 156. So this is very similar to the last one. Notice that this angle we can work out because we know how many sides to this polygon there are. This angle is an equilateral triangle, so this angle will always be 60. And then once we know those two, we can then figure out A by taking it all away from 360, because all of these points around there, around the dot, will add up to 360, because there will be a little circle around there. So we'll start again from figuring out what we can for the polygon that we know the number of sides of. So for the one where n equals 10, our interior angle, because that is the angle on the inside of the shape, will be 180 minus 360 divided by n, which is 10. So that is going to equal 180 minus 36, which will be 144. So the angle here is 144, which will then help us work out what A is. So therefore A is going to equal 360, because they should all add up to 360, because they would all come together to make a circle, minus 144. Exactly, Bella, yeah. I'm guessing there's a typo. Yeah, yeah, good though. So we want to take it all away from 360. Perfect. So if you put this in your calculator, or you could also do this in your head, you'll get 156, which is the answer to A. That's what we were trying to show. Show that question, a bit of exam technique. Ignore the answer, ignore what you're trying to show, and instead work through as if you don't know the 156 and then compare at the end. So whenever you have show that, don't use the 156 in your answer, I'd suggest. There are exceptions to that, but I'd follow that as a general rule. So that's going to be A. So now we can use this to work out what the number of sides on the other polygon is. What's the 60 for? So the 60 is the angle, let's get this, for this triangle here. So we're told that that triangle there is an equilateral triangle. Equilateral triangles, all the angles in a triangle add up to 180. So if it's equilateral and all of the angles are the same, that will be 180 divided by 3, which is 60. So for any equilateral triangle, that angle there will always be 60. Okay, so then we do part B over here. Let me zoom out so that everyone can see this. I hope you can all see that. So work out the number of sides of the other regular polygon. So we now know what the interior angle of that regular polygon is. So now we can work backwards and we can say that 180 minus 360 divided by n equals 156. And now this is just an algebra thing. We only have one letter that we don't know, so we can rearrange this equation to find n, and that would tell us the number of sides. So the way that I would do this is I would take the 156 to this side and the 360 to the other, so I would end up with 180 minus 156 equals 360 divided by n. I would take these two away. So that is going to give me 24 equals 360 divided by n. So I just move it up a little bit, times across by n, so then I can say 24n equals 360. Therefore n equals 360 divided by 24, which should give me 15, I believe. Yeah, 15. And that should be, n is just our number of sides, so that is our final answer, 15 sides. Ooh, let's move down a little bit as well. So yeah, so that's how you would do these. Fill in the gaps. Work first for any regular polygon that you know the number of sides of to find out its interior angle. Remember that angles around a point will all add up to 360. And hopefully you'll all be pros at answering these questions. How did you do the second step for part B? So do you mean this step? So oh, okay, so I did this all in one. You could do this any way you want, but I wanted to move the 156 over here so it sits with the 180. So putting all my like terms together. Because it's added on the right-hand side, I have to take it away to move it over to the other side. And then in the same step, I took the 360 over n and moved that over to this side. So that was minus on that side, so I have to add it to get it to the other side. And I just did that all in one step. So I got the minus 156 and then add 360 over n. Does that answer your question, Misam? Okay, these are only supposed to be short, quick revision videos, so fab. Yeah, so these are only short little revisions, so hopefully that packs all together everything you need to know about angles in polygons. It does have in the chat box there like a little link for some feedback, so if anyone can think of anything we can do better or anything you'd like, it's all really helpful. There are other revision sessions as well going on in the week for chemistry and computer science, so keep your eyes out for those. Oh, there is one last question. It's a good question. Are there such things as irregular polygons? Yes. Regular just means all the angles are the same. So for example, if I have a parallelogram, if I can draw one, like what we were doing last week, this would be an irregular polygon because these angles are the same, but they're different to these angles. So really regular polygons are the minority. They're the only the shapes where they're all the same everywhere. Yeah. I am going to head off though. So that is everything for today. I hope that was helpful for everyone watching. And next week, I can tell you what we're doing actually next week. No worries. Thank you for all being here. Thank you, Bella, for coming as well. So if you would like to know as well, next week we'll be doing circles. So we'll start looking at equations of circles. So if you found this useful, come along next week. Also have a look at the chemistry and computer science sessions as well. So they'll probably be useful for you all too. Have a lovely half term for those who are on it. Get back into work at school for those who've just finished it. And I will see you next week. Bye.